Hello, minions, and welcome to Mad Science with Dr. Frenetic. I'm your host, Dr. Frenetic, and let me tell you, I am sick to death of giant monstrous polynomials. I mean, seriously, whose idea was it to genetically engineer giant monster polynomials? What kind of sick, mad scientist would genetically engineer a... Oh, never mind, I just realized that was me. Well, fortunately, I also invented the factorizer. Using the factorizer, I can take this big, scary trinomial and break it down into two very easily dealt with binomials.
Stop.
Boo! Let's take a look at how it works using the handy-dandy explanatron.
Here's a trinomial. We want to factor this trinomial down to a multiplication of two binomials. The factored version will be of the form x plus something times x plus something. And remember that the something in the blank could be negative. If we follow FOIL, we know that the last two terms, the two blanks, are going to have to multiply out to 6. So now it's time to guess and check. Let's try 1 and 6. We multiply it out, and we get the wrong answer. Well, let's try again. How about 2 and 3? We multiply it out, and this time we got it right. So the answer is x plus 2 times x plus 3. Here's another one. Here, the last two terms need to multiply to negative 10. We try plugging in negative 5 and 2 for the blanks. Not quite, but how about negative 2 and 5? There it is. The answer is x minus 2 times x plus 5. Why not stop and give x squared plus 9x minus 10 a try? Pause the video and unpause when you're ready to see the answer. As always, we'll need to do some guess and check. Let's try 10 and negative 1. Perfect. Let's try doing this one a slightly faster way. We can use the linear term as a starting point for checking our answers. So, in FOIL, the outer and inner multiplications are the ones that yield terms in terms of x. So let's just do those. Here, we're trying to get our x terms to add up to 3x. Our outer multiplication turns out to be negative 1 times x, or negative x. The inner term is 10 times x, or 10x. This adds up to 9x, which is not equal to 3x, so we know that this answer is wrong. If we try it with 5 and negative 2, we find that out plus in is 3x, which is exactly what we were looking for. What if the x squared term has a coefficient? Well, now our binomials will each have an extra blank to fill. We know that the two x terms are going to multiply into the x squared term, so the coefficients on the x's must multiply to 2. Because of the coefficients on the x terms, we no longer have the guarantee that the second terms in each binomial will multiply completely to negative 9, but they will be factors of negative 9. Once again, we are left to do some guessing and checking. Let's try plugging in 2 and 1 for the coefficients of our x terms, and negative 3 for both constants. We'll use our out and in method to check against the x term in the trinomial. In this problem, our out term turns out to be negative 6x, and our in term turns out to be negative 3x, which is clearly wrong. But what if we made one of those negative 3's a positive 3? Still a little bit off. But if we try putting the positive 3 with the 2x, and the negative 3 with the 1x, we get the right linear term. Now we work it out to double check, and our answer is correct. Why don't you give this problem a try? Pause the video and unpause when you are ready to see the answer. So, once again, our answer will have coefficients on the d terms in the binomial factors. We'll have to guess and check. Let's try 2d minus 1 times 1d minus 3. Negative 1 and negative 3 are both factors of 6, so this is potentially correct. When we use the out and in method, we find that our d term comes out correctly. But let's work it out in full and check just in case. That's not right. Good thing we checked. So we try something else. Let's try 2d minus 3 times d minus 2. Again, notice that the coefficients on the d's multiply out to 2, And the two terms that are without variables are factors of 6. The out and in check tells us that our linear term is correct, so we work out the problem in full, and we find out that we've got the right answer.
Until next time, I've been Dr. Frenetic, and this has been Mad Science with Dr. Frenetic.